Hello, Assalamu alaikum. Today's our topic is moment of inertia. Now, before understanding moment of inertia, first understand what actually is moment. We will define this topic in a bit mathematical way, and why not in theoretical way? Because it's more understanding is when we come across stresses. Stress is equal to my over I. So more of its understanding is there. Why it is very important. So we will just cover the mathematical portion of moment of inertia, its calculation, even its definition in mathematical form. So before coming towards moment of inertia, initially let's understand what actually is moment. Now we know that the product of force and perpendicular distance is called moment, or even we called it first moment of force, first moment. Now this first movement can be converted into a second moment of force when we again multiply this perpendicular distance as written here. If this movement, above movement, is again multiplied by a perpendicular distance between point and line of action, it is called second moment of force. Now this second moment of force, I will underline it, the second moment of force is called moment of inertia. So this is completely mathematical. For its more practical purposes, on which factors it depends and what sort of importance it has with respect to civil structures, with respect to stresses, bending, etc. It's coming when we calculate stresses in strength of material is equal to my. We knew that this famous formula my over I. So how this I depends and stresses, so we are not concerned about it. It's just a rotational, second rotational, means second moment of force, moment of inertia. Now we often come across to find the moment of inertia not by force, as we know that moment is equal to p into perpendicular distance means x. So we usually in figures we don't use force p or f. We actually multiply this distance with area or mass. Okay, and we also, to calculate the moment of inertia, we have to multiply with square distance. Okay, so to calculate the moment of inertia, we knew that we need force and perpendicular distance square of perpendicular distance. Now usually in figures, in cross sections, we don't have forces, we use mass or area. So as written here, sometimes instead of force, mass or area, sometimes instead of force, mass or area is taken, and it is called second moment of area or second moment of mass. So we are going to learn the moment of inertia using our second moment of area. So all these things, second moment of area, second moment of mass, or even second moment of force, is called moment of inertia. It is usually denoted by I, and it has a unit of either meter power 4, millimeter power 4, so all the length units powering 4. So this is the concept of moment of inertia. Now what are the methods through which we find out the moment of inertia? There are only two methods through which we find out the moment of inertia. The first is roots method, as it is written here, and the other is integration method, initially roots method. Now this root method, I will again say that root method only have academic importance. We are not supposed to find out the moment of inertia with respect to roots method. It's just an academic value we usually give it. If I have to define the roots formula, I can say that the roots rule states that if a body is symmetrical about three mutually perpendicular axes, then the moment of inertia about any one axis passing through its center of gravity is given by. There are three formulas for different shapes: square, circular, spherical. Definitely this rule depend upon we. The first condition is that we should have a solid body, means three mutually perpendicular axes are in action, and even this particular body should be in symmetrical in all three axes as written here. Mutually perpendicular axes, symmetrically about three mutually perpendicular axes, and if we have all these conditions satisfied, then we can find out the moment of inertia from any side of a particular diagram. Like a square, we have this formula; for circle, we have this formula; and spherical body, we have this formula. Now in this whole, we can only say that only this factor s, we don't know what is this s, so it is written here down: sum of square of two semi-axes other than axis about which the moment of inertia is required to be find out. Okay, now I will simply say that now the note is written here. This method is only academic importance and is really used in field of science and technology these days. The reason for the same is that it is equally convenient to use the method of integration for the moment of inertia of a body. It's simply written here that we should use integration method to find out the moment of inertia. So coming towards our integration method, what actually integration method tells us? Integration method tells us to find out the moment of inertia, we just need two things: area and perpendicular distance square. Simple for you, moment of inertia is equal to a x square. This is by integration method, and there are theorems that you can find in any type of book of strength of materials, that what sort of theorem are there and how to prove this statement that moment of inertia is equal to area into x square. So these are cramming things, so you can go and cram these things and get a bit of understanding how you can drive this formula. I will not get into much sort of details. So now this is the integration. This is integration method through which we find out the moment of inertia. We just need two things: area and x square. Okay, now with the help of integration and other theorems, we will learn how to find out the moment of inertia of a rectangle, circle, triangular, semicircular and composite sections. All of these are quite important. So coming towards our rectangle portion, rectangular. Now what in rectangular section? So I have already told you, if we are finding a moment of inertia, okay, of any body, we are finding moment of inertia of any body, so we usually find out with respect to any axis, means any line. Okay, so if we are finding the moment of inertia of this box, we need to initially draw a line. This is my line, so with respect to this line I can find out the moment of inertia of this box. This line can be here, so you have to always remember where your axis or where your line is, which is the reference line through which you are finding the moment of inertia. Okay, so for a rectangular section, the moment of inertia with respect to this axis, and now we have already learned center of gravity in the previous lectures of strength of materials. You can always watched all those 4 parts of movement of finding center of gravity, so you can understand how to find out the center of gravity. To find out we have already found out the center of gravity, and we knew that the center of gravity lies here of this rectangular section. So we are going to draw these lines. Okay, this is my y-axis and this is my x-axis. So moment of inertia of a rectangular section with respect to I-axis means, now always remember that this x-axis is crossing the centroid of a rectangle. So a line parallel to x-axis or even x-axis, any line passing through the center of gravity and parallel to x-axis, we have the rectangle moment of inertia formula is equal to b d cube upon 12. Okay, and if now this is for x-axis. Okay, now for y-axis we have y is equal to b d cube upon 12. No, it should be db cube upon 12. db cube upon 12. Okay, so there's a bit of confusion how to remember that in which axis d comes with cube and in which axis b comes with cube. So I will give you a short trick to remember that. That in which case which dimension comes cube. So remember that x-axis. Now this is our x-axis. We knew the x-axis. To calculate the distance from x-axis, we knew that the distance is calculated in this dimension, and we knew that this dimension is in vertical and d. So whenever we are dealing with x-axis, okay, so the depth is always in action. So for I-axis it is b d cube upon 12. D in action, so d will be more than b. Okay, now if we are finding the moment of inertia in y-axis, so we knew that in y the depth, the length which is in action is this. Okay, with respect to this length and this distance, we find out at which point the box is. So this distance is usually b. So when we are finding the moment of inertia of with respect to y-axis, b is always more. So that's why the power of b is there. Now this I have told you this procedure to remember. This is a short way to remember. In I-axis it's bd cube upon 12 and its y-axis it's db cube upon 12. Okay, so this was the whole rectangular. So you have to remember these two formulas. Okay, you have to remember these two formulas for a rectangular section. Now proceeding towards our problem. This is written here: find the moment of inertia of a rectangle section 30 mm wide and 40 mm deep about x-axis and y. We have rectangular section, so we can say that find the moment of inertia of a rectangular section. This is the rectangular section 30 mm wide. Give it a second. 30 mm wide and 40 mm deep. So 30 and 40 mm deep about x-axis and y-axis. Okay, so we are free. We can draw the x-axis and y-axis at any point we want. We only knew the formula to find out the to find out the moment of inertia with respect to its center of gravity point, means this point. And if these x's are finding through these lines, so we can say that we are drawing here our axis. Okay, this is my x-axis and this is my y-axis. So the problem has gotten quite easier. So I knew that x is equal to b d cube upon 12, and my b width is 30 into 40 cube upon 12. I can get my answer. Likewise, here Iy, it is equal to db cube upon 12, 40 into 30 cube upon 12. Quite easier, you can calculate this from here. Now this was our first problem. We can also you can find out the moment of inertia. Now that was given in the question. We have to find out the center of moment of inertia about x-axis and y-axis. We draw our x-axis and y-axis here and here, and we find out the center of moment of inertia. That's quite simple. Now proceeding towards another question. Now it is written here, find out the moment of inertia of a hollow rectangle. Now this is a question that can a bit confuse you. Now this is here a hollow rectangular section. Hollow means a cutting. You can say hollow means a cutted section about its center of gravity. Okay, from the center of gravity it is cutted or hollow if the external dimensions are these and internal dimensions are these. Now we can say that external dimensions first. So we have a rectangle. I draw my rectangle. Okay, my external dimensions are 60 and 80. 60 always, 60 breadth 60 mm, and this is 80 mm. Okay, and other dimensions are, internal dimensions are 30 and 40. So I have already given this as 30 and this side pen is not working well. 30 and 40. Okay, so in this type of question, find the moment of inertia about its center of gravity. So with respect to the center of gravity, now this is the center of gravity. Okay, and it's a symmetrical section, so we actually don't need to find out the center of gravity in first. So we knew that the center of gravity will be here, so we can find out even in x-axis and in y-axis. So I am going to find out simply in x-axis. So I have formula for it's bd cube upon 12. Okay, so I am dividing this. This is my first section. The first section is the whole depth of a rectangular, means 80 and 60 both, and my second section is this 30 and 40. Okay, so for first section my moment of inertia will be b1 d1 cube upon 12. So I know the bd cube upon 12. So for first section the moment of inertia will be b1 d1 cube upon 12 minus sign show that our section is hollow, means the section we are going to minus will be cutting the first section. So for second section it will be b2 d2 cube upon 12, and we can find out. We know that b1 is 60 and d1 is 80, b2 is 30 and d2 is 40. So we can simply find out with respect to this. For a hollow section we just need to put a negative sign for the figure which is cutting it or hollow. So this was our first lecture. For as this video is getting a bit larger, so I will explain. So we have actually explained circle, triangular, semicircular and composite in the next video. We have learned what actually is moment of inertia, what is moment of force, what are its units, how to denote it, what are the methods, roots method, integration method and rectangle. In the next video we will try to proceed the other 4 different types, how to calculate the moment of inertia of circular, triangular, etc.